So far, we have been talking about monoatomic ions, basically ions made up of one atom. So an iron plus 3 or a Cl minus 1. Now, in this video, we're going to talk about polyatomic ions. These are a group of atoms, more than one, coming from different elements, and they're all held together by covalent bond, and they act as a unit, but they have an overall charge, okay? So the definition of a polyatomic ion is an ion formed by a group of atoms. They're all bonded together with a covalent bond, and they act as a unit. So they're all moving together as one unit. If you look in your book, table 4.3, there's a whole bunch of formulas and names of polyatomic ions. I just had it open in front of me here. Here it is, a whole bunch of them. So I don't know if it's clear enough. But anyway, you can look it up. It's in the ebook. It's in the hard copy book. I'm going to give you some key ones that I'm going to be working with. When you do your homework, it's, everything's open book, open notes, just look them up. But these are the ones that I really want you guys to know very well. There are 14 of them. Your book gives you way more than that. This one, NO3 minus, is a nitrogen with 3 oxygens all acting as a unit with a -1 charge. Periodic table won't help you with this. The only way to know this is to actually memorize them. This is nitrate. So index cards, write down the formula on one side, write down the name on the other, and they become second nature to you. Just keep them with you from now till the end of the semester, okay? The ite always has 1 less oxygen than the 8. So nitrite is NO2 minus. Notice they have the exact same charge, but the ite has 1 less oxygen than the 8. Okay? SO4 2 minus is sulfate. Remember how I said the ite has 1 less oxygen than the 8? So if I'm doing sulfite, it would be SO3 2 minus. So the overall charge, the sulfur with the 3 oxygens moves as a unit and has an overall charge of -2. Sulfate, overall charge of -2. Nitrate and nitrite, overall charge of -1. Okay, let's do some more. There are 4 chlorine-based ones. There's ClO3 minus is chlorate. 1 less oxygen for the ite. ClO2 minus is chlorite. Okay. The term hypo means low, like hypoglycemia means low blood glucose. So hypochlorite has even lower number of oxygen. This one over here is hypochlorite, not hydro, hypochlorite. Again, all these are in your book. Sorry, it's a little messy here. 1 more oxygen, ClO4 minus. This is called perchlorate. Okay, so far we have 8 of them. We have nitrate, nitrite, sulfate, sulfite, perchlorate, chlorate, chlorite, hypochlorite. Okay. A few more that I think are important for you to know. PO4 3 minus is phosphate. Okay. CO3 2 minus is carbonate. It's a memory thing, guys. If you have really, there are some things in chemistry that just have to be memorized, and polyatomic ions are just one of those things. Especially for those of you moving on into higher level chemistry classes like 1170 and 1180, this is going to be crucial. So I'm trying to give you a really good foundation here so that you can have them for higher level classes. All right, if you throw in a hydrogen in front of the carbonate, it changes the charge to -1, and now it's called hydrogen carbonate. 2 words, hydrogen carbonate. Another way of calling it is also bicarbonate. You may have heard of the bicarbonate ion. That's what this is. This is bicarbonate. Hydrogen carbonate is another name for bicarbonate. So you should know both terms here. Okay. OH minus is hydroxide. CN minus is cyanide. Okay. Okay, those are the negatively charged polyatomic ions I want you to know. I have one positively charged one that I need you to know, and that is NH4+, and that's ammonium. Your book has way more, and your homework is going to give you a lot of others, but these are the ones that I really feel you should know inside out and upside down and be very comfortable with. So nitrate, nitrite, sulfate, sulfite, perchlorate, chlorate, chlorite, hypochlorite, phosphate, carbonate, hydrogen carbonate or bicarbonate, hydroxide, cyanide, and then the ammonium ion. Okay, good. All right, so what are we going to do with these? Well, we're going to do exactly the same thing that we did with the binary compound. You can create compounds out of these. If I write down the name, you should be able to figure out the formula. If I write down the formula, you should be able to figure out the name, and then you will become brilliant at any ionic compound. So let's get started. Let's say I write down potassium carbonate. Okay, so exactly like what you did with the binary ionic compounds, you do the same thing. You look at potassium. Where's potassium? Group 1A metal, K plus, fixed charge. Carbonate, you'll have this memorized. Carbonate is CO3, 2 minus. Okay, now we do the same concept of crisscross the numbers, all right? Just never, ever, ever touch the subscript of the polyatomic ion. Leave it alone. Okay, don't ever change it. Don't ever touch it. The subscript of the polyatomic ion has to stay where it is, okay? You bring the 2 here, you bring the 1 here, you end up with K2CO3. Okay, let's try another one. Let's say I've got lead, Roman numeral 4, sulfite. Okay, lead 4, we already know, Pb 4 plus. Sulfite is SO3 2 minus. Okay, a little tricky here. We're going to crisscross the numbers. We're going to put the 2 down here and the 4 down here. Okay, so I'm going to give myself some room so you can see what I'm doing here. I'm going to go, here's the lead. I'm going to put the 2 of the sulfite, I'm going to bring it down here. And then the 4 of the lead, I'm going to bring it over here. Look at what happens. If you put it this way, it looks like you've got 34 oxygens. What you want to tell everybody is that you have 4 sulfites, not 34 oxygens. So you must use parentheses. So put in your notes, if you need more than 1 polyatomic ion, you must use parentheses. Do you understand what I'm talking about here? If you're going to have more than one of the same polyatomic ion, you've got to use parentheses. You can't just put that number or else it's going to look like I said, 34 oxygens. But then we have to do something else. Do you notice that this 2 and this 4 are both divisible by 2? Don't mess with the subscript of the polyatomic ion. Never, ever, ever reduce that. But the one that says I need 4 sulfites can be reduced. So this 4 and this 2 are both divisible by 2. So you end up with Pb, open parentheses, SO3, close parentheses, 2. This divided by 2 is 1. This divided by 2 is 2. So lead 4 sulfite would be this. Okay. So I'm going to do one more final video for this series, and we'll just practice a whole bunch of these, mix it all up, and hopefully you will feel comfortable with this chapter.